All right, it is a dreary day late in the year 2025 in the paradise of Southern Ohio. Today I wanted to give an introduction of this channel, which is a vegan fitness, climate related channel. Well, they're both polarizing along with every other topic, so why not? So, what credentials do I have to even be talking about this? Well, I'm not a climate scientist and I haven't published any peer review papers or anything like that. What might be relevant, I was an actuary for about 20 years and I did pass all the exams and became a fellow in the Society of Actuaries in 2003. I've forgotten a lot of that stuff, but hopefully I retained some sense of probability and statistics, which you need a lot of in this field. There is a lot of number crunching. And I wanted to focus a lot on the concept of aerosol masking. It's a very infrequently discussed topic, probably because it's kind of inconvenient. And the basic idea is the burning of fossil fuels, especially coal, releases sulfates into the atmosphere. And this has the effect of reflecting solar radiation and therefore creates a cooling effect. And first of all, I really didn't pay that much attention to climate change. I mean, I knew about it until about 2016. And at that point, I did hear the term aerosol masking. Then in 2017, summer of 2017, I came back to Columbus. I had been living in Charlotte, and that was a relatively cool summer. And I remember saying, wow, this might be the last cool summer we ever get. And as a few years went by, it did get a little warmer, but I was racking my brain trying to figure out why are we just not hitting that many record highs in the summer here in the Midwest, generally in the East. And then it was about September of 2023, something triggered me to look into aerosol masking as the culprit for this lack of summer heat. Because originally I thought it was just evenly distributed all around the planet, but it turns out, as I used a tool called earthnullschool.net, which it provides a rendition of the globe. You can click on any point and it'll give you certain data at that location, and you can go back to 2016 and see what it was at any date in the last 9 years or so. And one of the parameters you can look at is the sulfur dioxide level in the atmosphere. And when I combined that with National Weather Service records, it became really apparent what was going on, that in the eastern U.S., especially here in the Ohio Valley, we're getting a considerable cooling effect from the aerosols from burning coal. I know it sounds hard to believe, but that's the story. So what does the correlation look like between low sulfate regions versus high sulfate regions as far as heat? And there are a couple ways to look at this. One is to look at it geographically, comparing a certain time period, looking at what kind of heat records were set in the high sulfate region versus how many records were set in the low sulfate region. So what I did was I looked at the last 10 years and took 6 sample cities and looked to see how many records were set in the last 10 years, June, July, and August, in these respective locations. So let's start out with the high sulfate cities. And first off, we have Nashville set 4 records in the last 10 years. Pittsburgh didn't set any. Des Moines set 1. Peoria hit 1. Charlotte hit 6. And Memphis hit 10. So that totaled up to 24. Did I mention Des Moines? Des Moines had 3. Anyway, on to the low sulfate region. Start off with Cheyenne, which had 25. We already beat the first group. On to Key West, which had 18. You get down to southern Florida and the sulfate level is a lot lower. Seattle had 20, Tucson 48, Corpus Christi 44, and Amarillo hit 41. That totaled up to 196. So about 8 times more records were set in the low sulfate cities when compared to the high sulfate cities. Another way to look at correlations is to look at some high sulfate locations and compare what kind of summertime heat were they getting before the coal burning era versus what kind of summertime heat are they getting more recently. And a lot of the coal plants were built around the late 40s and early 50s. That's kind of when there was an explosion of it. And there were more built as we went through the 70s and 80s. And the dividing line is most of them were built kind of Topeka, Kansas, and east. And that's what you see on Earth Knoll School. You see a big drop off in sulfate level when you get about west of Wichita. It varies day to day, but that's the general idea. So what I did was I considered pre-1955 to be the non-coal burning era. So I looked at 1900 through 1954 as the what would have been presumably low sulfate environment, and I compared that to the last 30-year period and the last 20-year period, and I wanted to see how many 100-degree days were set back then versus more recently. And for Atlanta, back then, it was averaging about 7.2 days per decade of 100-degree temperatures. More recently, in the last 20 years, they've averaged 8.5. Now, in the last 30 years, 6.3. So really, it's pretty much a break even. And certainly Atlanta has gained a major urban heat island effect compared to back in the first part of the last century. But yet, it's a break even on extremely hot weather. The nights are getting hotter, it's getting warmer in general. The thing with the aerosols, they have the biggest effect is when you need it the most, when it's hottest. It's really uncanny how it works. Now, for Peoria, everybody says, well, you can't use the Dust Bowl because that was anomalous and that will really skew the results. So I looked at 1900 through 1954, but I excluded the 1930s. So this would look even worse if I didn't do that. But for that early period, Peoria was averaging 1.2 days per decade of 100-degree heat. Now, in the last 20 years, they've only averaged 0.45 days per decade, and over the last 30 years, 0.37. So Peoria is getting a lot less 100-degree weather in recent decades versus way back 100 years ago. And that's, again, excluding the Dust Bowl, that decade, the 1930s. Evansville, same thing, I excluded the 1930s. And back in that earlier period, 3.3 days per decade of 100-degree heat. In the last 20 years, only 1.4. In the last 30 years, 0.9. Big drop off again. Kansas City, same thing. I threw out the 1930s. 4.3 days per decade was what they were averaging then. In the last 20 years, they've averaged 2.4. In the last 30 years, 2.6. So again, they're not getting nearly the heat, extreme heat that they used to be getting. the last 15 years, well, really 13 years, especially that part of the Midwest, the heat has been missing in action. But it's overdue. Based on historical records, Kansas City is really overdue for some hot weather. Then finally, I looked at Albany up in New York. And back this time, I didn't throw out the Dust Bowl because they weren't really affected. So looking at 1900 through 1954, they were averaging, well, they don't get as much 100-degree heat, so I used 96 degrees. How many days did they hit 96 or more? And for the early period, it was 1.8 days per decade. The last 20 years, it dropped to 1.1, and the last 30 years, it was 0.7. So again, a big drop off. We could do more cities, but I think you get the idea. And if this doesn't convince you, there's more data out there, and I might do more videos. I want to do a video on the Dust Bowl. That is really revealing and tells you in a lot more detail just how big of an effect this is having.